Welcome to my course in Python. Today we will go through everything that you need to know in order to set up a minimal project in Python, install packages, and manage virtual environments. We'll start off with a bit of a general introduction to Python. Enjoy. Python is an interpreted language. That means the code that you write is not directly compiled into machine code, but there's a step in between. So first it's compiled into bytecode, and this bytecode is then executed by an interpreter. That makes Python roughly 100 times, maybe 200 times slower than other languages, like for example C++ or Rust. However, what makes Python so popular is not its execution speed, but the speed in which you as the programmer can actually write something, test something, and come up with a program that works. Yet performance is not a problem in Python. That is because the libraries that actually need performance, like scientific libraries or machine learning libraries, they are written in C++ or in CPython and then are just wrapped in Python. That means when you write Python code, you actually call C++ stuff under the hood. And that gives you the performance back that you need. However, there's one caveat. Python has something called the global interpreter log, the GIL. That means you can always only run one thread. That is to say, you're always just using one CPU at a time. If you want to use more than one CPU, you have to spawn two Python processes. To be a bit more precise on that, you can multi-thread in Python, but only one thread at a time is executed. So why is Python so popular? In my opinion, that is because it's so easy. There's a huge community of users, and these users are very nice and write a lot of packages that they make publicly available. So as a result, it's very easy for you to join in and write code, and like there's a 99% chance whatever you're doing, there's already a package for it written by someone else that you can use. So following that thought, we will have a look at how to manage your Python projects and how to install packages. And after that, we will dive into Python. The absolutely most important package in Python is pip. Pip is the package manager. In order to install it, we first update the operating system. So sudo apt-get update. Actually, nowadays you can do it like this. I just did that, that's why nothing remarkable is happening here. And then we are going to install pip. So we do that by doing sudo apt install python 3 - pip. I also just did that, that's why nothing is happening. One small hint, what you can do is you can type yes into that, so you don't have to press the Y key all the time to confirm all the installations. So now that we have pip, the next thing we're going to install is a package called venv. And you will see in a moment why that is very important. This package is extremely important because it helps us separate projects from each other. It does this by installing all of the dependencies and packages that you use in a project in a folder within that project folder. So this gives us a clear separation from other projects, and you won't have any version conflicts between packages that you install. Especially in fast developing machine learning libraries, this can be a lifesaver. You use the module by typing python 3 - m for module. venv is the module name. And then you pass venv as the folder name where you want the virtual environment to be put in. Most people use venv, that's sort of the standard. So if we do this, this takes a while. Now we activate it using source, or you can also do .venv bin activate. And now this virtual environment is active. And on Ubuntu you even see this indicator here. This has a couple of side effects. So the first one is it creates a symlink for Python. So now Python 3 is pointing to this here. However, this is not it's just a symlink, so it's not a complete copy of your Python, it's just a link. Another side effect is created a variable called virtual env, I believe, that is pointing to this virtual environment. And another thing it does, it put itself on the path. So you see it's here. That is because we have a script to deactivate it, and otherwise this wouldn't work, right? So this is how you start and deactivate this virtual environment. So now let's install something. We do that with pip install, and then you type the package that you want. For example, numerical Python. Numerical Python includes a lot of, as the name says, numerical functions. If we do this without being in a virtual environment, it's going to install into your home directory. So this user is called Ubuntu, that's why it installed into Ubuntu, and then a hidden directory called .local. So I just did that, that's why it's already there. So we want to undo that by uninstall. Yep. And now we do it the proper way by installing it into our virtual environment in this folder. But this time, we're going to install an older version for whatever reason. Yeah, you do that with these two equal signs. So now it installed this older version. If you now want to update to the newest version, you just use upgrade. Minus upgrade. So it uninstalls the old one and installs the newest one, so 1.26.3. To install more than one package at the same time, you can use requirements files. You will find these requirements files essentially in every single Python project because everyone uses them to manage their requirements. So let's go ahead and write one, requirements.text. So let's say we want pandas, which is a data science library, and we want numpy, and for numpy we want at least version 1.25.0. So you saw the syntax for specifying the versions is the same as with stuff on the console. So let's install that, install -r requirements. And now it will go through the file and install all of the packages in there and also their dependencies. And that is pretty cool because that saves you a lot of time use. So you see here 6 is a dependency. And if you want to see exactly what is installed now, you can do pip freeze. And that will print out all the packages and the versions that are currently installed. So this is very useful if you want to create further requirements files. For example, say you want to ship your app to a customer or so, and you want to ensure that he installs exactly the same packages as you had on your machine. So we can use pip freeze and pipe that into another requirements files, require, and we call this prot. This is usually also what I use in my Docker containers to ensure that I have exactly the version that I want. So let's have a look. Looks exactly the same. Now we have all the ingredients together to actually start our first project. Even though this might be a very small project, or even your first project, I suggest that you start with a very structured and clean approach to this. This is because you want to make it a habit to structure things properly from the beginning. It is because, let's be honest, you're not going to come back and fix the structure afterwards. That's just too much work. And secondly, think about quality. If what you wrote is very good at performing a specific task, someone else will come and try to reuse this to fix his own problem. So in order to write really good code, it not only has to be good at fulfilling a task, it also has to be modular so that someone else can reuse parts of your code. And it also has to be understandable. That's one of the most important things about programming. And yeah, it's the best idea to make this your habit just from the start. The structure I'm going to show you is my own personal taste, so take it with a grain of salt. But later on, if you want to deploy this with, for example, Docker, this will be very useful. So what I always do is I have a folder called src for source. This is where all my Python files will be in. In this folder, I have a file called main, which, as the name suggests, is the main file. And this will be the main entry point for this project. So this is the file that we actually execute with Python. So we'll be looking something like this. However, nothing is in the file, so nothing happens if you execute it. In the source folder, I always have another folder called after whatever the app is called. So for example, app name. In this folder, this is where all the implementation of the app goes. So this is what we will do later. Only thing we do today is we create a init.py. This essentially makes this folder a Python module. And that allows us in the main file to do something like from app name import yada yada. So this is where all the code will be imported in this main file. Yeah, that's it for today. I hope you enjoyed today's tutorial. See you next time.